Welcome to Maths for You channel. A past question on complex numbers. Sketch in an Argand diagram the locus of the points that represent complex numbers z satisfying argument of z minus 3i equal minus pi by 3. So find the locus of z. The condition given, the argument of z minus 3i equal minus pi by 3. Let's start the question. I can write z equal x plus iy is an arbitrary format. X, y are variables. The condition is given. The condition for the locus of z is argument of z minus 3i, that is equal minus pi by 3. We can write that this z minus 3i in the form of two complex numbers. Argument of z minus 0 plus 3i equal pi minus pi by 3. So if the argument is given, then the locus of z is a half line. The reason for half line as a starting point, a pivot point. The pivot point is 0, 3. Z minus 0 to 3i, so 0, 3. So that is on imaginary axis 0, 3. So the line, the locus of z, which is line, half line, will be starting from 0, 3. The start point or pivot point is 0, 3. The angle is given minus pi by 3. So that is the angle minus pi by 3 is a clockwise pi by 3 from the horizontal axis, or the real axis, parallel to the real axis. So that's minus pi by 3. So that's the locus. We do a bit more to locus. The locus of z is the line starting from 0, 3, and the angle making pi by 3 to the clockwise, to the real axis. I could write the argument, I could just write it in the form of x, y. So I just want to get that equation, the line equation, x plus iy minus 3i. So if you could make real and imaginary, the y minus 3, the coefficient of imaginary, or imaginary part, x is the real part, it's y minus 3 over x, will give us the tangent, the argument, which is tan inverse. The argument is minus pi by 3. Minus pi by the tan minus pi by 3 will be negative pi by 3. So y minus cross multiplication, y minus 3 equal minus 3x. From that, y equal minus 3 root 3x plus 3. That's the locus. That's the equation of the locus of z. The locus obviously will cut the real axis at A. We can find A as well, the coordinates of A. At A, the y, of course, the y coordinates is 0. So 0 equal root 3x plus 3. The root here, 3, minus root 3x minus root 3x plus 3. Then the root 3 on the left hand side, root 3x equals 3, that x equal to root 3. Because of 3 equal root 3 squared. Then the root 3, the square cancel out, root 3 left. So A, the coordinates of A is root 3, 0. So on a real axis. Right, let's they look at the second question. Hence or otherwise. So it's just a very strong hint that the first part will help us to solve the second part. find the minimum value of z minus 1, the module of z minus 1, so this modulus is a distance, z minus 1, such that argument z, conjugate of z plus 3i equal pi by 3. So in other words, the vector z minus 1 to the argument is given. Let's see. Z minus 1, the modulus of z minus 1, the argument is this. But because of the actual, the hint given to us, so the only thing we can kind of make use of it, the locus of z possibly something to do with this. So the argument of conjugate of z plus 3i equal pi by 3, it's we trying to make it the locus of z. So it's just a bit of work to be done to prove this one is argument of conjugate of z plus 3i equal pi by 3. Let's see. So the conjugate of the whole thing, z, the conjugate of z plus 3i, so just the conjugate, will turn the reflex of x-axis or the real axis minus pi by 3. So if we could put one line on the top, make that angle go negative. So argument of conjugate, entire conjugate of z plus 3i equal minus pi by. Now we need to prove that the conjugate of the conjugate z plus 3i is the first part. See how far we can go. So the conjugate z plus 3i, that's the whole thing conjugate. I just wanted to write that z, conjugate of z in the form of xy. So x plus iy is z. So the conjugate of x plus iy is x minus iy, and of course 3i, and conjugate of the whole thing, or the bar on the top for the whole thing. And then we can separate that real and imaginary, x minus y minus 3, the imaginary i, and of course the bar on the top. So remove the bar, just make that minus to plus. So now without the bar on the top, so this has become x plus y minus 3i. Now separate that, x plus iy minus 3i. That is x plus iy is z minus 3i. Yeah, this is what we had on the first part. So the first part says, what is it? Argument of z minus 3i equal minus 3 pi. So we started with this argument of conjugate of z plus 3i, and the whole conjugate is minus pi by 3. Now we proved it, argument of z minus 3 equal minus pi by 3. That is exactly the locus of z from the first part, the locus of z from the first part 1. Right, that part is done. Now what we have to do, find what is z minus 1. Z minus 1 is the vector or complex from the locus, any point of the locus, to 1 on the real axis as A. So B. B. Yeah, the B. So the B is the coordinates of B is 1, 0, because of this z minus 1, 1, 0. So BC is a vector, z minus 1 is the complex, z minus 1. Z is any point on that locus is z is minus 1. BC, just BC, is a modulus of z minus 1. But z minus 1 minimum, that distance has to be a has to be a shortest distance. If it's the shortest distance from a point to a line, must be a perpendicular distance. So the perpendicular distance from 1, 0 to locus, that's what we have to find. If that's the case, if it's a perpendicular line is BC is a perpendicular line, that will make ABC as a right angle, a triangle. From the sketch you can find. Right, ABC right angled triangle. So ABC is a right angled triangle. We need to find BC. It's one of its side. So BC equal AB times sine pi by 3. AB is the hypotenuse. AB is hypotenuse, yeah. That AB sine pi by 3. Then AB is, if you look at that sketch again, A is root 3, B is 1. So root 3 minus 1. AB root 3 minus 1. AB is root 3 minus 1. Sine pi by 3, root 3 over 2. So it's, this student should know, or use the calculator. Root 3 over 2 calculator give you in points. So just you should know sine 60 is pi by root 3 by 2. That is pi by 3. So root 3 minus 1 times root 3 over 2. So half as a common. Root 3 times root 3 is 3. And root 3 times 1 is minus root 3. So this is the distance, minimum distance from the locus of x, locus of z to the point 1, 0. So it's a bit of work. It's just because of we've been given hence, then as a hint from the first part, which is the locus of z. So we need to prove that. We did that. Thank you. Please subscribe the channel and please share these contents with fellow students. Thank you.